Good morning, afternoon. Not sure when this is going to get finally uploaded. Kids, students, villagers, I don't know. I'm starting slow. Anyways, this is long overdue. So this is 19.3 surface areas of pyramids and cones. Hopefully some of you already got started on this. I forgot to post the video last week, and yeah, I apologize. But good news, this is the last set of videos when we're done. We're almost done with this class. So cool. All right, let's get going. All right, first up, pyramids. Pyramids are pretty easy because they are also shapes that are really easy to visualize. So if you look at pyramids, they always have some kind of shape at the bottom, a square or a triangle, or is what most of them have. And so if you look, you've always got four sides of that pyramid that are triangles. And since we're talking surface area, we're just using the area of a triangle formula. Okay. One thing that takes a second to kind of visualize is that for these triangles, you always need the base and the height, right? But the height is not the height of the pyramid, it's the height of the slant, okay? So you need to find out the slant height of the pyramid, which they use this little L, this cursive L to sign to whatever. I can't think of the word. So slant height. All right, so here's the formula they use if you want to use the whole lateral area system, which again, totally fine. If that makes sense to you, you can use the lateral area. If it doesn't, that's fine too. You just think of it as you have four triangles and one base, whatever shape the base is. If the base is a square, base is a square. All right, so that's those. Okay, that's the general setup. Let's go through some of these. I don't have my worksheets, my gray sheets, so I can't really work through those on this video, but let's go through some of these. All right, so if you look at this triangle right here, we do not have the slant height. We're gonna skip that one. We're gonna go. I need one that doesn't have it all set up for me. I know. That's weird, right? But whatever. Here we go. Screen's going dark. Let's go to this guy. Okay, so we want to figure out the lateral area and the surface area. So if I'm looking at this, okay, I'm gonna be honest. One of the things that's really hard about this section is that this triangle and the base is almost always an equilateral because otherwise you don't have enough information to solve it. So even though this does not look like an equilateral triangle on the bottom, it is. Because again, if you didn't have that, there's no way you could solve this. Okay, so I'm going to do these two, and then I'm going to move on to cones. Okay, so for this one, the base is really easy. It's a square, right? And it's 6 feet. So my square is just going to be 6 times 6, or 36, and that's going to be the area of my square. Okay, now I want to do the triangle. All right, so on this, they tell us the height here, okay, and this distance. So this distance is half of this because it's a square. So this distance in here is going to be 3. And so you're going to use a lot of Pythagorean theorem in this section. So I have the height. So if you look, this isn't actually a triangle I can really use for anything, but it will get me the slant height. The slant height is the hypotenuse of that right triangle. Okay, so I'm going to use this and this to find the hypotenuse. So we're going to say 3 squared plus 8 squared equals L squared. Okay, so this is 9 plus 64 equals L squared. So what's that? That's 73. Come on. Can't you give me a nice number? So 73 is equal to L squared, which means that L is equal to the square root of 73. Lovely, right? This is going to be a pain because I'm going to have all these square roots. Okay, and now I can't do this without a calculator, but we're going to. Okay, so if I want to figure out the area of this triangle, so remember we have this blue triangle. We just got the height is L. Okay, we know the base is this 6. Okay, so it's going to be 6 times L divided by 2. All right, so we're just going to say that is 6 radical 73. Okay, 6 radical 73. Now here's the nice thing about these pyramids. So because you have multiple triangles, so if I were to say divided by 2, so that would be the area of those triangles. But I have 4 of them. So I would multiply it by 4. This 4 and that cancel out, and you end up with just 12 radical 73. So that is your lateral area, which is the area of all the triangles on the outside. Okay? So to get the total surface area, I would say this plus this. So we would say 36 plus 12 radical 73. And that would be the answer to that one. Okay, let's do one more of these. How am I doing on time? 5 minutes? Cool. All right, this one. So this one's a little easier because we shouldn't have any, what's the word? Square roots, hopefully. We might. We'll see. All right. So first thing I want to do is the triangle on the outside. Okay? So we know the height. And again, this is an equilateral triangle on the bottom. All of these sides are 4. If they're not, the triangle won't work and you can't solve it. Okay, so that means this base is 4. So we know this triangle is 4 and has a height of 6. So we would say it's 6 times 4 is 24. Divide by 2, but we have 3 of them. So times 3. So what's 3 times 24? It's 3 times 24 would be 60, 72. So we have 72. Oh, I guess I could have just done 24 divided by 2, which gives me 12. 12 times 3 is 36. So all the triangles, or the lateral area of this guy, is 36. Okay, now the base is a little trickier because you're going to have to use this technique, which you're going to use over and over and over again in this section. So it's an equilateral triangle, which means this is 4, this is 4, this is 4, right? But we don't want to do anything crazy. We want to use Pythagorean theorem if possible. So what we do is we split this triangle into 2 right triangles. So if we split this, that means this base right here is 2. And so now I can do a Pythagorean theorem to figure out what the height is. I can make another, so I have this little right triangle that is 2 by 4. So I'll say 2 squared plus h squared equals 4 squared. So we got 4 plus h squared equals 16. So that means h squared equals 12. Oh, there we go. We got another square root. Lovely. Okay, so we got h equals radical 12. Okay. So the height is radical 12. The base is 4. So we are going to say 4 times radical 12 divided by 2. Right? So 4 times radical 12 divided by 2 will give me the area of this base triangle. So 4 divided by 2 is 2, so it's just going to be 2 radical 12. So we add those two together, and that is our total area. Okay, that is pyramids. Okay, I'm going to start on cones. I'm just going to talk a little bit about how they work. I'm not going to do any examples. I'll do some examples later. Okay, so here we go. Cones. The tricky thing with cones is the outside, like the part that's wrapped around the outside, is not a normal shape. It's this Pac-Man shape. Okay? The base is a circle. Base is easy. But the cone part, the outside wrapping, is a little different. And so to do that, you've got to use this formula here. You want to know what the area of the whole circle is, okay, and the area of the sector. Let's see. I think they give you a formula for it. Here we go. Okay, so the lateral area, or the wrapping, okay, is equal to, I believe it's the slant height. Yeah. Pi times the radius times the slant height. Okay? So pi, radius you're given, you just need the height of this slant. So how long the outside of the triangle is. Not the height, but the outside. Okay? So that hypotenuse. So a lot of times in this, again, you're going to be making that triangle using the Pythagorean theorem. But on this one, you want the hypotenuse. That's the important part, not the height. Okay? So let's look at one of these real fast. Let's do one real quick. Let's do this 4, 6 one. Okay, so we want to do this guy real fast. So, okay, we'll start with the easy one. So they tell us that the diameter is 6, which means the radius is 3. So I'm just going to write that over here. Radius equals 3. Okay, so radius equals 3. That means the area of my circle on the bottom, circles are pi r squared. So that's going to be r squared, which is 3. 3 squared is 9, so we have 9 pi. So our circle on the bottom equals 9 pi. Okay? And then we want to do this guy, the lateral part, the cone. Okay, so remember, so the height is 4. Okay, this is 3. So we want to figure out what the hypotenuse is. Okay, so 3, 4, 5. Okay, so that's that special triangle I told you a long time ago to memorize because it comes in handy. 3, 4, we want to figure out that one. Just so for whatever future reference, posterity, we're going to solve this with Pythagorean. I'm going to say 3 squared plus 4 squared equals L squared. Okay, 3 squared is 9, 4 squared is 16, equals 25. So 25 equals L squared. Square root both sides, you get L is equal to 5. Okay, so we know L is 5. So that means this L equals 5. So again, our formula, back up here, for the cone part is pi times the radius times L. Okay, so the radius was 3, so 3 times L is 15 pi. So the cone part, draw my little Pac-Man. Pac-Man is equal to 15 pi. Add those two together. They're both in terms of pi, which means I can just add them. Okay, so that's going to give me 24 pi as my final answer. Okay, that's cones and pyramids. Cones are a little weird, I know, but again, it's all about that Pythagorean theorem and dealing with stuff in terms of pi. I'm going to stop here. Yeah, if you have any more questions, send me a message. Maybe I'll make another video talking about this, but for now, I just want to get the other video that's about area spheres up. Okay? Thanks, guys. Have a good one.